concepts. Okay, so other part is very other important part is normalization and relational algebra. Okay, so relational based on the relational algebra, SQL is based on relational algebra. So most of the concept is covering, we have covered in SQL, but we will also tell you the concept of the algebra part. Okay, so algebra means that how actually SQL is formed, and SQL is using the relational algebra to execute the queries. Okay, so that is how your algebra works. In a similar way, your ER diagram is the first step of creating effective tables, because with the help of ER diagrams, you already know that how to convert ER diagram into tables. Okay, so based on the previous concept that we have studied, now this particular lecture I'll try to revise all the things that we have done, and I will give you some questions so you get the overall thing that how the question in the exam will come. Okay, so this is a very interesting question. This particular question is from GATE exam. It's a very good question. Okay, so I think it is from 2005, GATE 2005. Okay, so this question specifies you the concept of foreign key. Okay, so if you remember the concept of foreign key, you can easily solve this question. Again, I'm saying what is basic. So if always try to learn basic stuff. Okay, so if you have a good basic understanding of a subject, you can easily be able to solve any GATE question, any ISRO level question, any kind of a question, or you can always try to form any kind of a table as well if you have a good understanding of ER diagram. Okay, so now this particular question is based on the concept of foreign key. I know that I think you already know. I have shown you different scenarios how foreign key works. I've also shown you foreign key on the similar table on a recursive relation as well. Okay, so this is one interesting question, because you have given with the table. Suppose this is the table that is given to you. These are the values that are given in it. Okay, so these are the values that are given in it. Okay, so what are the things that are given to you? The table is given to you. One thing is given that A is a primary key. Another thing is given C is a foreign key, which is referring to A. Okay, so this is a recursive relationship. Okay, so again, I've told you that this can happen in tables, that a particular foreign key can refer to another foreign key, can refer to another primary key in the same table. Okay, so what they have given you that this particular foreign key follows the concept of on cascade delete, on delete cascade or cascade delete. Okay, so in books sometimes they use on delete cascade. What is the concept of it? That again, I give you example. If you remember that there is something called your department ID name. Again, this is department ID, and this particular key is a foreign key which is referring to another table, that is a department table. Okay, so this is employee name, employee number, employee name. Okay, so now on delete, suppose there are two particular departments and we have deleted one department. Okay, so what will happen? What particular, if you are setting the foreign key, if you are setting the foreign key on delete cascade, then what will happen? Suppose there are employees that are referring to CSC department. So there is another employee that is referring to ECE department. Okay, so when you delete this whole department, the CSE department, what will happen? The employees that are related to it will also be deleted. So this particular process is called on delete cascade. Okay, so now understand this point. They are saying that C is a foreign key which is referring to A, and foreign key is following the concept of cascade delete. Okay, so it means whenever you delete something, another deletes will also be triggered. Okay, now you have to understand which particular thing is this. Now another that they have started with the deletion. Now they have deleted the tuple 2 4. Okay, so they have deleted the tuple 2 4, and now they are asking that with the deletion of 2 4, which particular to preserve the referential integrity, uh, what the additional tuples that will be. Okay, so I'll write it. So after deletion, they have deleted the row 2 4. Okay, this is the action that is done in the question. So they are asking what are the additional tuples that will be deleted with this action. Okay, so I also give you what do you say, options as well. Okay, so this is first is 3 4 and 6 4. These two rows are deleted with by deleting this. B is 5 2 and 7 2. C is 5 2 7 2 and 9 5. D is 3 4 4 3 and 6 4. Okay, so take like 5 minutes, and if you do not understand the question, let me know and try to solve this one and tell me what will be the answer from A, B, C, D. Okay, so post your answer in the chat box. It's very important. Okay, so don't worry, I will show you how to do this question. But if you know the concept of foreign key, you can easily solve this. Okay, so take like 5 minutes and solve this question and let me know the answer. Okay, so anybody try take more time. So just see that how this particular concept will be triggered. Okay, so again I will tell you that how can you solve it easily. Now in a way that we have, I have given you examples. There are two tables here, but there is one table here. So you can make the same entries here by making this a two table entry. Okay, so I will show you that this is one table. You can write it like this here, and then this is another table. So same table, there is no difference in that. Now I will say that this particular, I'm just forming this example like the upper example that we have done by deleting the CSA department. You are deleting wherever there is one. Okay, so just think like that this particular C is referring to A column. Now it's become the same example. Now try to solve it and let me know the answer, because I think now you can easily solve it. Okay. So now your 2 4 row is deleted here. Okay. So just wait a second. Here, rather than writing 2 4, I will say delete it from the department side. Again, it is the same table, so 2 4 will also be deleted from there as well. So don't worry about that part. Okay. So I just want to know that by deleting this, what additional rows are deleted. Okay. So take 2 minutes more. I think you can easily do it now. Try it. Okay. So now understand this point. It is again very important concept here that is being covered. Now see here what is happening. I'm deleting 2 4. Okay. So now you see that this particular row, or sorry, this particular column is depending upon another column. Okay. So it is like that a particular person, and there are two persons here in the examination hall, and one person is copying from another person. Okay, so just it is straight down copying everything whatever this particular student is writing on his sheet. Now what it happens that after some time the student thought that I have done something wrong, and he just tried to delete some part of the what do you say, uh, sheet. So because this particular student is depending on this one, so again it will again start to delete particular parts of the list. Okay, so based on this, now this is the student that is copying from this particular student. Now in this student I have deleted, this student has deleted 2 and 4 entry. Okay, so because this is the A is dependent, A is the main parent of C. Now see what is the main atomic value in the A that is deleted. Okay, so 2 is deleted here. So see here, if there is anywhere 2, you can delete that row also. So it is like that we have deleted the department ID 2, which contains CSA department. And now check, whoever has the department ID 2, you will delete those rows as well. Now what will happen? Actually, this is the same table. So actually this is also deleted. So I'm just showing you in a different table so that you can easily understand. Okay. So because it is very difficult to show it in the same table, because that will just make a lot of thing complex. Okay. So now it is the same table. If I'm deleting something from here, it is deleted from here as well. Okay. So now with the deletion of this, I'm deleting this from here as well. Again, from the parent table, you are seeing 5 is deleted and 7 is deleted. Now check if there is anywhere 5, 5 is there. Okay. So you can delete this portion. Is there anywhere 7? No, there is no 7. So now you are deleting 9 5. So I am again deleting 9 5 here. Now check, is there anywhere 9 here? No, there is no 9 here. Okay. So the additional entries that are deleted with the deletion of this particular 2 4 are these three entries. Okay, so 5 2 7 2 9 5. Okay, so check it, is the answer I think is 527295, because this is the answer. Now you may be thinking that what actually is happening. Okay, so now if I take another scenario, I'll take another scenario like there is another row entry there which contains suppose it contains 8 9. Okay, so again if you see here 9 entry is here, that is deleted, so you have to delete the ninth entry from this as well. Okay, so because this is the same table, I'm writing it like, okay, so now I'm deleted 9. So with the deletion of this, the again the concept of foreign key is again triggered. Okay, so with deletion 8 is every is C containing any 8 here. Again, if it is contained in C, you can delete it. Okay, so that is how actually foreign key command works. Okay, so if you have set on delete cascade, now what will happen that when you deleting a particular foreign key, that on delete means that whoever is depending on it, he will also delete that portion. Complete row, actually complete row. Just understand that one column will be assigned a foreign key, and that column will be dependent upon other table column. Okay, so most probably it will be the same name, but it can be a different name also. Just keep in mind it can be a different name. Okay, so till here if anybody has any doubt, let me know. Okay, so okay, so this is again, you seeing these are very interesting questions. So you will not find these kinds of questions in any book, because when you do these kinds of question, your concept of foreign key and basic concept will become very clear. Now you will know how the foreign key works, actually how the foreign key works. Okay, so this is another gate question. So this particular thing is I have already covered in second 2 lectures back, and that was the constraint violation. So we have done 4 kinds of constraint. That was domain constraint, if you remember, referential integrity constraint, and then we have done entity constraint, and then we have done key constraint. Okay, so now this particular thing is based on referential. This particular question, I think it was from 97 or 98. This particular question was based on referential integrity constraint. Okay, so they are asking about the constraint violation. Violation means that what action you are doing that is violating this one. Okay, so if you remember, I have also shown you the different kinds of violation in terms of insert and delete. Okay, so now suppose the question is given like, let there are two relations are a comma b comma c, and there is another relation s are d comma e comma f. Now they are saying that D is the foreign key. So this D. So I make this relation so you will be easily understanding. Okay. So D is saying that D is the foreign key. So D is this. This is the foreign key. So I can make this table there. Like, yeah, you will understand it like that. Correlate everything with the example that I've shown you. Suppose now I'm saying that D is the foreign key. It means it is referring to uh, a primary key of R. Suppose primary key here is A. Okay, so D is the foreign key which is referring to a primary key of R, that is A. Okay, so think of it like that. This is the department ID, and this is your what you say employee table. Okay, so now they are saying that what are the consider we are considering 4 operations here, 4 operations. Out of these 4 operations, which operation can cause a violation? Okay, so out of the options given, which which operation or option can cause referential violation, referential integrity violation? Okay, So now the four constraints that are given to you, again, it is already covered in the lecture. So remember, if you do not remember, I'll tell you, but try to revise it. So that is why this particular session is conducted, that you should revise. I'm taking those questions that will implicate the revision part. Okay. So I'll also cover some of the basic that we have done. So C, delete from R, and then D, delete from S. Okay, so there can be more than one option because I've shown you violation in insert and delete. So there can be multiple answers to this question. Okay, so try to solve it. Take like 5 minutes and think of it. Okay, so I think you can easily solve it. Try it. Okay. So again, I'll repeat that part if you don't remember. So what actually happened? It's again there are there is
Sir,
a yes.
sir, is it C.
Is it C? Yes, it is C. But there is other option also. Okay, so I'll tell one by one. We try to do the operations. Okay. So first operation that is saying that insert into R. Okay. So again, this is what you say the main table or the parent table because this particular D is referring to A. So this particular table, what I say, S is referring to R. Okay. So if I add something, if I add new department here like department 3 CSC, there is no problem in that. I can do that. Okay, because this is the main table. In the main table, parent table, we can do any entries without affecting anybody. Okay, so where will be the problem that we are entering something that is does not exist in this column that it is referring to. Okay, so that will be a problem, but I don't think that there is no problem if you enter any value in this one. Okay, so this is not a violation. Okay, so you can insert anything. This is not a violation. Now saying here, it is saying insert into S. Now this particular thing can cause a violation. Okay, so can cause a violation. Now how can it cause a violation? Because I'm inserting into S, what I can do, suppose there are three values here. Okay, so this is department mechanical and this is civil department. Okay, another entries are also there. Okay, so what I'm doing is that I'm entering some values here, suppose A, B, C, D, that is not a part of this column, so I can enter 100 here. Okay, so when I'm entering 100 here, that is a violation because referential integrity constraint tells you that you cannot enter uh, you cannot enter outside the range of this particular parent table column. Okay, so by inserting you this particular insertion can cause a violation. Okay, so insertion can cause a violation. So you the first answer is this one. Insertion can definitely cause a violation. Another thing is that deletion from R. Deletion from R is the same scenario that we have done in the previous uh, example as well, that this is a department and I'm deleting the CSE department. Okay, so if I'm deleting the CSE department, what will happen? What will happen to those people that are belonging to CSE department? Okay, so there were three solutions that we have discussed in the violation. The first solution was that you should refrain. Refrain means you should not delete anything from the parent table. Second solution was delete cascade. Okay, so second solution was that when you are deleting the department, you can delete the those entities or those entities or those rows that are relating to the department. Okay. Third solution was on delete set null. Okay. So when you are deleting something, you are just setting null. You are putting a value of null here. You can put any value, or you can put null here, or you can put any value. Okay. So it means those persons that are belonging to this department, in place of 3 there will be put a null or any other value that you want. Okay, so there were three solutions. Okay, so again this is the what you say after violation, what you do. So they are only asking about the violation, they are not asking about any of this. So if you delete the department, there will be a violation here. Okay, so this is again, this delete from R will cause a violation. So the answer is B and C. Now check the D part. Delete from S. Okay, so when you delete from S, you are deleting some value from S. This will not affect any way. This will not affect R in any way. Okay, so if you are deleting some entries in S, it will have no effect on the parent table because this is a child table and it is depending upon the R. It is like that you are copying from a person and you are deleting some part of this particular paper that you have copied from other person. That particular person will not be affecting whatever you are doing in your answer sheet. Okay, so that is how if you delete this particular column or any other entry, it will not affect this one. So there is no violation. So violation will not be caused with this B and C option. Okay, so based on, again I'm telling you that whatever I'm teaching in the lecture, based on this particular question is asked. Okay, so try to be vigilant in the lecture, and if you are not, I know that most of the time that we when we when we are watching continuously, it will be like it's very difficult to be stay vigilant because because of your hectic schedule. But just try to be that when I'm telling you that this particular thing is important, so just focus all your energy to this particular concept. Okay, so if you do not remember this, what are the violation, what is the differential integrity constraint, just watch the video 2 lectures back, and you can watch every video in 2x 3x, because I speak very slowly, and you can easily watch uh, the videos in 2 and 3x to save your time as well. Okay, so everything you can watch every video in like 15-20 minutes. It will not take more than that. Okay, so at the end of the day, always try to rewatch the video so that the concept stays with you. Always try to make some notes. Okay, so again, I have provided you the PPT as well. The PPT part is already there. I'm giving you some extra things. Okay, so in the form of notes. Okay, so try to write something on your copies, on your pen, so just remember the concept. Okay, so when we write something on a piece of paper with the help of a pen and a pencil, that will stay longer in your brain. Okay, so again, if you're seeing here, I'm not telling you anything without logic. Okay, so everything is with logic. If you understand the logic, again, based on that logic, you can solve anything. Okay, so I'll revise the previous concept that we have studied. Just wait for a second. Okay, so again, what we have done till now is this, just to refresh your mind, because this is one of the most important part that we have studied. Okay, so all the concept like relational model to foreign keys, different primary keys and other things. So just a little bit of a revision so that we can move ahead with the next topic of relational algebra. Okay, so now again, whatever relational model was introduced by code. Okay, so whatever the base main things that is there in your DBMS, it is done by this person. Okay, so relational algebra is also formed by this person, that is based on set theory. Okay, so again, it uses mathematical expressions or mathematical relation and the concept of set theory and the predicate logic. So PL, again, I will tell you PL part. PL was based on what do you say, true false statement. So I'll tell you when it comes there. Okay, so again, database is used to represent a collection of relationship. We already know that. So again, to revise the normal terms, relation is also referred to as a table, attribute, field, or column is very similar. Tuples and record is similar. Schema is the header. Schema is the header, like name, roll number. This is referred to as a schema. Instance is whatever is written inside. Okay, so one name is Sam. This can be referred to as an instance. Okay, so domain can be what you say. The domain of this particular column is that you can enter only characters. Okay, so domain of the roll number column you can only enter int. Okay, so the domain can be that the range of value that you can put in a column. Okay, so keys, I'll tell you different types of keys. In this particular part, I've covered all the keys. Okay, so degree of relation and degree of ER is a different thing. Okay, so if you remember in ER, the entity type that are participating in a relationship, that is called the degree of the relationship. Okay, so degree here is 2, but the degree of a relation means degree of a table. So however, the number of columns. So number of columns here is 1, 2, 3. So the degree of the relation here, relation means degree of the table is 3. So keep that in mind. Okay, the total number of attributes in which the relation is called degree. Okay, so the degree in ER is different than degree in tables. Tables mean relation. Okay. Last part is cardinality. So cardinality in ER was the maximum number of relationship in which a entity is participating. Entity type or entities that are present in the entity type are participating. And in here, the cardinality is referred to as the number of rows that are present in the table. Okay, suppose there are 3 rows or 4 rows. So the cardinality of this relation or table is 4. Okay, so here is the example here. So this is the schema
This is referred to as the attribute. So name, roll number, phone number, address, and age is attribute. So again, these have five tuples or five rows, and the cardinality is referred to as here five. Okay. So the roll number here is referred to as a primary key because it is underlined there. So the roll number is a primary key. So domain can be that you are seeing here the roll number is in the int form, that is referred to as a domain. Domain of this roll number is that you can only enter int values. Okay. So degree here, what is the degree of this table? 1, 2, 3, 4, 5 columns. So degree of the table is 5. Okay. Cardinality is also 5, depends on the number of the rows. Okay. So see here, there is something called a domain. So domain permits permitted atomic values for an entity. I think we have already done. So the example would be that the month of an year can accept all the month name or numbering from 1 to 12. So if you are defining anything called a month, you cannot go beyond 12 because there are only 12 month in a year. Similarly, you can the domain of a particular column can also be specified as a date. When it is specified as a date, it can only accept a possible format like this particular thing 1 12 20 21 2001, something like that. Okay, so if you enter anything else, it will give you an error. Okay, so another thing is referred to as this is an example of it. So f a birthday date is referred to this particular column is following the constraint of date, and this particular SSN number is following numbers only. So constraints are already there that are put on it. So domain means a set of values that you can put, a range of value that you can put in a table's column. Okay, so this one, and then there are keys. Okay, so keys we have already covered, I think 4 or 5 keys. What was primary key, then super key, then candidate key. I also told you about composite key as well. So all the keys that we have done, I will go one by one. There are additional keys also. Okay, so key is anything that can identify a particular column, or sorry, particular row or record from entries of hundreds of thousands. Okay, thousands or lakhs of entries. If you are able to identify a particular person from that table, that will be possible with the help of a primary key. Suppose there are around 20,000 students in a college, and every student will have a unique, what you say, a roll number. So based on the roll number, I can be easily able to identify a particular student. Okay, so that is why the concept of keys come here. Okay, so key is used to access the stored data very quickly and smoothly. So again, it can also be used to create relationship because we have studied the foreign key, and foreign key will always, most probably, will be forming a relation with the primary key. It will always be referencing a primary key. Most of the time, it is not a rule. Keep that in mind. Foreign key will not always reference a primary key, but again, it generally it references a primary key. Okay. Another thing is that there are these kinds of keys that we have studied. So primary key studied these. I'll tell by one. Okay. So primary key has the characteristic. There are three characteristics that is important to primary key. First characteristic is uniqueness. Another characteristic is not null. Okay. One other characteristic that it is minimal in nature. So minimal means, another characteristic that it can be only one. Okay, so there can be only one primary key in a table, not more than one. Okay, so there are four particular properties that are attached to it. Okay, so suppose in a table, if you're seeing here EID and SSN number, they both represent a uniqueness here. Okay, so you can choose this primary key or this primary key, that depends upon you. Okay, when you're choosing, when you're a database designer, you are saying that I'm choosing SSN number as a primary key or EID as a primary key. That depends entirely on the designer. Okay, so in this particular case, EID is chosen as the primary key. So
other key that you should have chosen the primary key, but you had not chosen, this other key will be referred to as alternate key. Okay. Okay, so if there are two primary keys in a table, you will refer to, because there will be only one primary key. So you, whenever you choose one key, other key will be referred to as a alternate key. Keep that in mind. Okay. Okay. So now another example of a candidate key. So candidate key again is a sub superset of primary key. Okay. So now what are the features here? So this is a less restricted form because primary key has four property. Uniqueness, it will have uniqueness, first property. It will have what you say called, it will not have a ordinal part. It will have what you say, what are the relationship? It has a minimal, okay, minimal part also. Okay, so they are, if you're seeing here, when we are going upward, there is the candidate key is not that much strict. Okay, so there can be more than one primary key. Okay, so more than one primary key is candidate key is also possible. Okay, so again, there can be two or three or four candidate keys in a table. The fourth is again, it will be always be a minimal. Okay, so if you are thinking that in a table, roll number, if you are thinking roll number is a candidate key, you can add anything to a roll number and name, because uh, roll number will provide you uniqueness. Name will combining roll number with name will also provide you uniqueness. Combining roll number with any other column will always provide you uniqueness. Okay, so that is why they are saying this condition minimal. So roll number plus name. So you think that name, if name is unique, you can assign a name a primary key, but this is not happen. But roll number is always unique. So you will assign this particular thing as a candidate key. Okay. So the only difference with the candidate key is that two differences with the primary key. That first, it does not follow any not null part, and second, you can enter null values in a candidate key. And second is that there can be more than one candidate key. So in this particular example, this is a candidate key as well as this is also a candidate key. So because SSN number also shows you uniqueness. Okay, so keep that in mind that whenever you are studying book, most of the time they will be referring key part as a candidate key. Now why they do that is because the examples are given like this. They are only giving the schemas of the example. They will not be giving you the, what do you say, the entry part. Okay, so they will not be giving you the entries in a table, because the not null constraint can only be, you can only tell the not null constraint by seeing the entries of the table. If there is a null entry, you can say that this particular thing is not a primary key, it will be a candidate key. So some books use primary key and candidate key interchangeably, but most of the books use candidate key. Okay, because they are always be giving you example of a schema. Keep that in mind. Okay, so now what is this super key? Super key is very simple. So alternate key is there. Alternate key, I think I have already told you. Alternate key, candidate column other than primary column is referred to as alternate key. Okay. So these two are the candidate for primary key. So I have chosen this one. So the remaining one will become alternate key. So keep that in mind. Now, super key is just by you just take the uniqueness row, any candidate key, and you combine, you put any other column with it. It will become a super key. Okay, so roll number name will become a super key. A roll number address will become a super key. Roll number name plus address will become a super key. Okay, so super key is just the superset of all of it. It only contains one particular property, that is only uniqueness. Again, it is one of the, it is not following any rule, so it is following only one rule. It is following candidate key was following two rules and primary key is following, I think candidate key is following three rules. Let me see. Candidate key is following three rules and primary key is following four rules. Okay, so that is why it is a subset. Okay, so primary key is the subset of all of it, and if anything is a primary key, then you can again refer to it. Okay, so that is why that the candidate key becomes a superset, because it is following three rules. Okay, so if a particular key follow four rules, then it will be termed as a primary key. But if it only follows three rules, you can term it as a candidate key. So every primary key, you can say that every primary key is a candidate key and a super key because it is following the three rules as well the one rule of super key. Every candidate key you can call it as a super key. Okay, but so every super key cannot be called a candidate key and every candidate key cannot be called a primary key. Keep that in mind. Okay. So in this example, I think super key they are taking EID combined with the name is a super key. SSN combined with department is also a super key. You can take any other thing and combine it. Okay. So I think I'll cover the next part in the next lecture. This is it for now. Any doubt, let me know. Thank you for listening.